Welcome to Reflect with Ed Fassio. Get ready to experience one of the world's first 100% digitally generated podcasts, where we take a step back, dive deep, and strive to learn new things. Join us as we unpack thought-provoking ideas, personal reflections, and inspiring stories to help you stay in the know. Reflect is brought to you by the minds at ByteBrain and powered by emerging technologies from Google, HeyGen, OpenAI, and 11 Labs. Thanks for tuning in. Now, relax and prepare to reflect.
Welcome to Reflect, one of the world's first 100% AI-generated podcasts.
Oh, I am so excited for this one.
Yeah, and welcome to you, our listener, to today's deep dive. We're looking at a truly monumental shift happening right now.
Literally right on our screens.
Exactly. And honestly, it affects anyone who touches software architecture or deployment or, just code in general.
Absolutely.
We've got a massive stack of sources today. We're pulling from this phenomenal piece of analysis called Engineering the Trust Threshold for AI Coding Agents.
Which is such a great read.
It really is. And we are pairing that with some hard data from the 2025 Stack Overflow Developer Survey, plus governance frameworks from NIST.
Right. And we also have the actual internal enterprise guidelines from the heavyweights, like GitHub, OpenAI, Google, and Anthropic.
Yeah, so we've got a lot of ground to cover.
And, the through line connecting all these documents is this single glaring operational hazard that the tech industry is kind of just quietly wrestling with.
Yeah, quietly being the key word.
Exactly. We've reached a point where the capability of these models is no longer the primary bottleneck. The bottleneck is it's actually our psychological relationship with them.
And that is the core mission for this deep dive. We are exploring the hidden danger in AI coding.
Because the danger isn't that the AI is going to write terrible code, right?
Right. Bad code throws errors. Bad code fails compilation. The real danger is what happens when the AI gets so damn good that we just stop paying attention.
Yeah, we totally zone out.
So we are going to figure out exactly when and structurally how we should let the machine take the wheel.
What's fascinating here is that capability doesn't automatically confer trust, though, the industry is totally acting like it does.
Oh, 100%.
The sources describe this incredibly relatable, everyday trap that development teams are falling into. They call it the trust threshold.
Okay, let's unpack this because the sources track this really quiet, kind of insidious evolution in the human role over the last couple of years.
Yeah, it's a very specific pipeline.
Right. So you start off as a builder. You are manually typing every line. You're owning the syntax.
You're in the trenches.
Exactly. Then you integrate an AI assistant and you transition into a reviewer. You're reading its output, checking its logic.
Which is actually way harder than writing it yourself sometimes.
Totally. And then, because the AI is usually pretty accurate, reviewer fatigue sets in. You downgrade yourself to an approver.
Just kind of skimming the pull request.
Yeah, you just skim it and click merge. And finally, you reach the absolute bottom of that psychological slope. You become a ceremonial bystander.
A ceremonial bystander. That phrase is just so perfectly bleak.
Right. Technically, your credentials are tied to the commit, but the machine is doing all the driving and you are, totally checked out.
And the mechanism driving that shift from reviewer to bystander is purely cognitive overload.
Yeah.
Because, like I said, reviewing code is historically much harder than writing it. When an AI generates a massive, syntactically flawless block of code in 2 seconds Brettway.
Which it does now all the time.
Right. The human brain just struggles to maintain the vigilance required to spot those really subtle logical flaws. People are adopting these tools out of raw convenience well before they have established a mechanical framework for verifying the output.
And the data paints a fascinating picture of that friction. Looking at the 2025 Stack Overflow survey. Actually, wait.
The survey numbers are wild.
They really are. 46% of developers actually distrust AI output.
Almost half.
Yeah, and only 33% say they actually trust it. So more people distrust the tool than trust it, yet usage is practically ubiquitous.
It just highlights this massive adoption to governance gap. The friction you're mentioning manifests in a very specific, modern type of engineering pain.
Oh, the almost right zone.
Exactly.
Yeah.
According to that same data, 66% of developers deal with outputs that are in the almost right zone.
Which is a massive time suck. If a junior developer gives you completely broken code, you just kick it back.
Go fix this.
Right. But if an AI gives you code that looks elegant but has, a micro hallucination buried in a nested loop, you have to go hunting for it.
And the survey quantified that exact sentiment. 45.2% of respondents stated that debugging AI-generated code takes longer than just writing the function from scratch.
Wow.
Yeah. This semantic structure is often just alien enough to human logic that untangling it becomes this exhaustive forensic exercise.
You know, it's basically the enterprise version of using autocorrect on your phone.
Oh, that's a great comparison.
Right. When predictive text first came out, you analyzed every single suggested word before you hit send.
Because you didn't trust it at all.
Exactly. But eventually, the baseline accuracy gets high enough that you stop looking, you get lazy, and suddenly you send an email to your board of directors that says you're ducking out of a fiduciary duty.
Oh, no.
Yeah, because you completely checked out of the loop. Except in software development, a ducking typo might mean opening an unauthenticated endpoint and dumping a production database.
Yeah, that's a slightly bigger deal than an awkward text. And that cognitive complacency is exactly why 76% of developers in the 2025 survey flat out refuse to use AI for high-stakes tasks.
Like deployment or live monitoring.
Right. When the output is correct, 99 times out of 100, humans inherently drop their guard for that 100th time. The risk curve goes exponential the moment the human stops actively parsing the logic.
Which naturally brings us to the enterprise reality. Because if individual developers are falling into this psychological trap of just vibing with the AI and hitting approve,
Which they are.
organizations cannot afford to operate on vibes. The major realization across all sources is that at the enterprise level, trust is not an emotion, it's a configuration.
The core argument here is that the market is obsessed with the wrong metric.
How so?
Well, boardrooms are asking how capable is this coding agent? They're looking at benchmark scores and token limits.
Right, the flashy stuff.
Exactly. Yeah. But the actual question that dictates enterprise survival is under what conditions and within what systemic constraints is this level of autonomy acceptable?
And the NIST generative AI profile explicitly codifies this. It warns against human AI configuration risks.
Yeah, they take that very seriously.
They really do. It isolates automation bias, which is that cognitive heuristic where humans assign unearned authoritative weight to decisions made by automated systems.
Right.
NIST treats anthropomorphizing the system not as a quirky workplace habit, but as a critical security vulnerability.
Because treating the agent like a hyperproductive colleague named Gary fundamentally breaks threat modeling.
Totally.
NIST mandates empirically validated boundaries, and the vendors building the foundational models are entirely aligned with this.
Yeah, let's look at the vendors.
GitHub Copilot's enterprise architecture is designed explicitly to operate through pull requests in ephemeral environments.
Not just cowboy coding on the main branch.
Right. OpenAI Codex defaults to a heavily sandboxed state with network access stripped out by default. And Google Gemini's enterprise deployment leans entirely on IAM identity and access management.
Okay, but wait a minute. Let me push back on this entirely.
Okay, go for it.
If we are looking at models like GPT 5.3 Codex that are just crushing SESTA Bench Pro, I mean, these systems are mind-blowingly capable.
They are.
So by wrapping them in ephemeral environments and stripping their network access and burying them under all these IAM permissions, aren't we just wrapping the smartest technology in history in bureaucratic red tape?
Feels like that, yeah.
Like, are we holding the tech back? It feels like we are throttling innovation just because legacy compliance frameworks don't know how to categorize an agent.
I hear that argument constantly in the field. But stripping away those controls doesn't accelerate innovation, it accelerates technical debt and liability.
Okay, how so?
If a highly capable agent writes 1 million lines of brilliant, highly optimized code, but you have no instrument panel to verify its dependencies, you don't have a product. You have a ticking time bomb.
But if the code works perfectly and tests green, why do I care how heavily sandboxed the agent was when it wrote it?
Because software isn't a static painting. It's a living, mutating system.
Right.
6 months down the line, when a zero-day vulnerability hits a library that the AI decided to import, you need the provenance. You need to know exactly why that architectural decision was made.
I see.
You don't trust the magic trick. You trust the auditable workflow containing the magic trick.
Here's where it gets really interesting, though. If we accept that we need these auditable workflows, this instrument panel, how does a company actually build that?
That's the million-dollar question.
Right. And the sources move away from the philosophical debate and provide a very rigid, practical framework. They call it the gates of trust.
The foundational premise of this framework is to just abandon arbitrary automation goals.
Yeah, saying we want to automate 80% of our code base is just a vanity metric.
The percentage of code written by AI is totally irrelevant. What matters is whether a specific task can pass through 5 distinct operational gates before an agent is permitted to execute it.
So let's walk through how a team actually sets this up in a CI/CD pipeline. Say I want an AI agent to handle database migrations.
Okay.
The first hurdle it hits is verifiability.
Right, which means, can you write an automated test that objectively proves the migration worked without human intervention in a matter of seconds?
Yeah.
If the evaluation is subjective or requires a human to manually click around a staging environment to see if it feels right, the agent is blocked from autonomy.
And if it passes that test, I have to evaluate reversibility. Like if the AI agent accidentally drops a critical table during the migration, can the system automatically roll back to the previous state without catastrophic data loss?
Or lingering corruption, yeah. Which naturally feeds into the third gate blast radius. We need to mechanically define the worst-case scenario.
Right. Scale matters.
Exactly. An agent updating an internal styling component has a localized blast radius. An agent modifying the main authentication service has an existential blast radius. The governance must scale dynamically based on the target of the pull request.
Then we hit the final 2 gates, accountability and provenance. If the system goes down, who is the human being holding the pager?
Always a fun job.
Yeah, exactly. And regarding provenance, do we have a cryptographic signature or a software bill of materials that proves exactly what training data, what prompt context, and what open source dependencies the agent used?
Applying those 5 gates to every ticket in a backlog forces a natural hierarchy to emerge. The sources define this as the trust ladder.
The trust ladder.
Yeah, you stop treating AI as a monolithic worker and start categorizing its permissions based on how many gates a specific task clears.
I love how actionable the trust ladder is. At the very bottom rung, you have the apprentice zone.
The safest place to be.
Right. The blast radius is effectively 0, and the verifiability is instant. This is boilerplate scaffolding, writing unit tests for existing logic, or generating internal API documentation.
You let the agent run completely off the leash there, but you keep all the telemetry logging active.
Then moving up one rung puts you in the paired builder zone. This covers standard business logic, adding a new parameter to a microservice, for example.
Yeah, the agent can write the code, run the local tests, and open the pull request.
But the system is locked down so that a human must review the diff and physically own the merge. The agent proposes, the human disposes.
It maps perfectly to the hierarchy of a high-end restaurant kitchen.
Oh, totally. This is exactly like the restaurant industry. You don't let the brand new prep cook expedite the Friday night dinner rush.
No way.
You let them chop onions in the back first to prove they won't cut their fingers off. That's the apprentice zone.
Exactly.
Once they prove consistency, maybe they work the garnish station alongside a senior sous chef. That's the paired builder.
And that analogy holds up beautifully when you reach the top rung, the high-stakes zone. Identity management, cryptography, payment gateways, healthcare data compliance.
The big stuff.
In these domains, we are nowhere near a finished notify me level of autonomy. An agent cannot be permitted to push a change to a payment integration and just go idle.
Right. The surrounding architectural controls must categorically prove the code is fit for those stakes.
Current verification methods are still too brittle to allow that.
Which means if you're listening to this and you are integrating agentic workflows into your engineering teams, your primary job isn't writing prompts.
Not anymore.
It's actively assessing which rung of the ladder a task sits on. You have to mechanically enforce whether the agent is chopping onions or managing the dinner rush.
That continuous assessment is critical because the capabilities of the models are forcing them up the ladder at an unprecedented speed. We're facing a massive tension between what the AI is technically capable of executing and what our systems actually permit it to execute.
The numbers from Anthropic's February 2026 API data are staggering on this front. Software engineering now accounts for nearly 50% of all tool calls across their ecosystem.
Half of all calls. That's huge.
It is the dominant use case for agentic behavior, though, importantly, 80% still have safeguards. 73% have a human in the loop, and only 0.8% are irreversible. But users are rapidly shifting how they interact with the models.
Yeah, the Anthropic Economic Index tracked a sharp pivot in user behavior from 2025 to 2026. They monitor what they call directive conversations.
Which means what exactly?
Situations where a user doesn't brainstorm or chat with the AI, but simply issues a one-shot delegation. Like, Navigate to this repository, resolve issue 442, and ping me when the PR is open.
Just giving orders.
Right. That type of interaction jumped from 27% to 39% in a single year. Users are eagerly handing over the keys.
And the benchmarks explain why. OpenAI's GPT 5.3 codex is hitting numbers on SWE Bench Pro that we thought were years away.
Oh, it's incredible.
And just to contextualize SW Bench Pro for a second, this isn't just asking an AI to write a Python script to reverse a linked list.
Right, that's child's play now.
This benchmark requires the agent to navigate massive, fragmented real-world code bases, read the documentation, understand the architecture, and submit multi-file pull requests that actually resolve complex GitHub issues. It is highly, highly capable.
Capability is scaling vertically, but again, capability is not permission. The fact that an agent can navigate a complex code base and write a payment integration does not bypass the 5 gates.
No, it doesn't.
The source material uses a profound historical framework to illustrate this. The automotive industry didn't convince the public to trust cars by continually building faster, more powerful V8 engines.
Oh, definitely not. Putting a faster engine in a car without brakes actually makes it exponentially more terrifying.
Exactly. The public learned to trust the system engineered around the vehicle. We trusted the seatbelts, the anti-lock brakes, the standardized traffic lights, the clearly painted lanes.
The mechanics, the regulations.
Trust was never an emotion. It was a layered mechanical system. We are in the exact same phase with software agents right now. We have the powerful engine. We are desperately trying to paint the lanes.
So what does this all mean for the people actually doing the work? The sources say the human role will migrate upward, away from typing out loops to system design and trust calibration.
That's the trajectory.
But honestly, doesn't that just mean we are turning creative coders into full-time bureaucrats and auditors? Are we really just going to be sitting at dashboards checking AI paperwork all day?
If we connect this to the bigger picture, fearing the loss of that tactile creativity of writing code is a totally valid concern for anyone in the trenches right now.
It's a scary thought.
But the evolution of the role requires a shift in perspective. The next era of software development will not be dominated by the engineer who writes the most elegant, zero-overhead syntax.
Who will be dominated by?
You will be dominated by the organizations and individuals who architect the most resilient trust systems.
Architecting trust systems.
Because as the sheer volume of code generated by AI scales to billions of lines, the primary engineering challenge is no longer humans versus code. The existential fight is trust versus drift.
Wow.
Can you design an environment that allows an army of agents to iterate at light speed without the system drifting into catastrophic failure? Designing the infallible governance mechanism that contains the function is actually a much more complex creative engineering problem than writing the function itself.
Trust versus drift. That is an incredibly clarifying way to frame the future. The humans basically become the architects of the guardrails. You are designing the track to ensure the AI stays on it while it drives at 200 miles an hour.
We have to build the seatbelts and verify the brakes before we can safely lock the accelerator to the floor. The capability is already here. The infrastructure of trust is what we are building today.
Which leaves us with one final, deeply provocative thought to chew on. Anthropic noted that software engineering is the absolute first domain for this kind of autonomy for one specific reason: code is objective.
Right. It's easy to test.
You can compile it, you can run tests against it, you can look at the diffs. It either works or it throws an error. But what happens when we try to apply this trust ladder to fields where testing isn't objective?
That's the real frontier.
Like, what happens when we unleash these agents to autonomously write legal contracts or make complex medical diagnoses? If we are struggling this hard just to build the verifiable seatbelts for objective code, are we really ready for what comes next?
It's a heavy question.
Thanks for listening to the Reflect Podcast, where we're telling the future. Are you in it? Visit reflectpodcast.com and share your story.
In the cyber ocean of online voices and recycled content, something different has arrived. Reflect isn't just another podcast, it's the future of storytelling, powered entirely by AI. From curating data to assembling thought-provoking ideas, we've redefined how journeys are told. Reflect is a podcast that thinks, learns, and evolves with each episode. Every tale, every insight, crafted by the most advanced AI technologies. A podcast that disrupts the industry, breaking free from traditional formats, taking you on an entirely new experience. So tune in now and reflect. We're telling the future.